Awesome. Well, Fred, Jacob, thank you so much for that talk. And you both have those two small children, so we appreciate all the time and energy you put into that for us. Now we're going to go to what I think is the most fun part of it is the Q&A. We've got quite a few different questions that have been coming up in the chat. Just a reminder, if you do have any questions as we go through, make sure you put them in the Q&A panel, and we'll try to get those answered to you live. So we'll go ahead and just kind of jump right into some of those questions. And so the first one is around error budgets. And so someone asked that in their company, they have several user-facing components, and they share several different backend services. How do you properly assign which error budget to use?
Jacob, you want to take this one?
All right, so if I understood the question correctly, so we have several different error budgets here, and then we have customers that are, does it sound like they're invoking a single service which may trigger off multiples? So in your case, you're probably going to want to watch all of them, depending on the context here. So what the customer is seeing ultimately is going to be the initial request. However, each service in play also has its own set of internal customers, is what it sounds like here in this case. So each one of those services ultimately is going to have some type of reliability or SLO defined for it, with the furthest upstream having the highest level of availability in order to meet the demands of what the customers are downstream. So the answer to your question would be all of them, if I understood that correctly.
Awesome. And kind of following on with that, again, with shared services, if you have a shared service with an issue that impacts a consumer's SLO or their budget, how do you appropriately assign that budget expense?
So this has been a question that we've discussed internally a lot. In any, unless you're running a single tier PHP app, you're going to have a distributed system nowadays. You're going to have a database, some front end services, and some ancillary services. And really, where we focused on is having error budgets for each of those individual services and using those to drive reliability work. So say if one service in the back end, exhausts its error budget, it's on that team to focus on reliability work, and they are they're essentially providing service to any of the we call them downstream facing the customer services. So they could have one or more different stakeholders who are consuming their service. So really, we take kind of an internal customer approach to this in terms of distributing the reliability work based on error budgets.
Awesome. Yeah. And so, this obviously was a bit of a technical talk. And so there's actually some questions about the implementation as well. Can you share any details on how you're using the API to get that custom metric count?
I would just direct you to take a look at the API documentation. Everything that you need to do is right there. They make it very simple. I used Python in my example. Just call the endpoint and just add up everything that you need. There's not much more magic there.
Well, I guess I'll tack on a question that was asked a little bit later. Is have you actually shared any of this code? Do you have any kind of how-to guides? Is Zendesk kind of putting this in the open source? Is this going to be a new standard?
So we are looking at publishing a follow-on blog to this, which contains more of the implementation details. As we mentioned, some assembly is required for this approach, but folks out there who have used Prometheus and some of the other systems that implement either histograms or latency band approaches will be somewhat familiar with this approach. So I'd say look to the Zendesk blog in the near future to get more of the how-to around this.
Awesome. Yeah, I think it's going to be great to share this out. I really, you said occasionally it messes with your head a little bit, but it totally makes sense once that clicks. So I think there's a lot of value in other folks, having that knowledge. So another question that came in, you covered SLOs, you covered SLIs, but where do the SLAs factor in at Zendesk?
So SLAs, service level agreements, are the end customer facing components, and we really leave that to our legal and contractual team. because they're, that's a legal document. That's a legal commitment. We're more focused with SLOs on making sure that our service is as best as it can be internally for our customers.
Awesome. And I guess, you mentioned the legal team. So, let me know if this question can't be answered. But how many of the individual customers are you monitoring?
When it comes to the individual customers and we're looking at the SLOs for them, they're in the hundreds range.
Okay. And then I guess not a question from the community, but from myself, when I was watching the talk, are you building customer specific dashboards to share with them?
The answer to that question is no. We use this data internally to drive discussion. The data that's shared externally, that's more something along the legal lines. So this data is all used internally so that we can learn how customers are using our systems and how we can use that to assign work and to better improve our systems and internal reliability.
Gotcha. Well, I'm sure they're at least benefiting from this work, whether they have the individual metrics on it or not, obviously.
And so, I can add a little bit.
Oh, yeah, please.
Oh, I was going to say I can add a little bit more to this. The reason we have put so much focus on making sure that these numbers are as precise and accurate as possible is we use them to drive reliability work for engineers. Engineers are one of our most valuable resources, and so we want to make sure that they're focused on the things that bring the most impact to our customers.
Yeah, I imagine that this has really focused a lot of their efforts. I've worked in a few different product companies in my time, and that 80-20 that you mentioned really resonates with me on a lot of levels as an engineer. You can have a few unicorns that really skew your numbers quite substantially, or use an obscure feature that nobody else uses that consumes a lot of engineering time. So being able to quantify that, I'm sure, has really helped drive some of the conversations internally.
Yeah, absolutely. And also too, when you do focus on those 20%, the problems that you're solving for them also benefits the others that you're not monitoring directly. They tend to, bring out the problems that are in the system that everyone else will benefit from.
Yeah, was it a rising tide lifts all ships, so to speak? Yeah. And so another question that kind of came in is, these inverse histograms, are you also using them for your traditional monitoring, or using them for other things that are not in this current set of work?
We are also using those for our monitors. The difference between using those for SLIs and SLOs versus monitors is the time scale. For monitoring, we want metrics along the lines of 1 to 5 minutes, whereas the evaluation period for SLOs is longer. Give it 7 days to an entire quarter's worth. So kind of we use the same approach there, but we have different timescales. We also used Datadog distributions to get kind of that real-time view of how our service is performing. So in a lot of cases, we'll have multiple tools to try and get the a similar answer, and that in the past has led us to some discoveries like perhaps one of the tools isn't operating quite correctly. Maybe we didn't push out the latest version of our latency band library. So we try to have redundancy where possible with these tools.
Yeah, that definitely makes a lot of sense. And then I guess kind of changing gears again, the way the Q&A works. There was a question around, why are you doing your SLIs differently from Google? Or is that not the gospel?
I can take that one. So we define our SLIs because we're using event-based SLOs. We need that delineation between good requests and bad requests. And really, if you look at a lot of the literature in the Google SRE book, the SRE workbook, even the more recent implementing SLOs book by Alex Hidalgo, a lot of that leaves the specific implementations as an exercise for the reader. And the implementing SLOs book actually goes so far as to say exactly that. And just when I watched Liz and Seth's video, that really made a lot of sense because it encapsulates the good request versus bad request approach. And if you read through some of the blogs out there, you'll find I've identified a pattern out there where you'll see folks, expressing an SLO as a line on a graph. That's not really correct. An SLO is the area under the graph over a certain time period. So there is still more work to be done in this area out there. And if you are embarking on this journey of SLOs, you have to decide kind of what the right definitions are for your approach.
Yeah, I actually really liked almost that like natural language approach that you took when you're making those common definitions. It distilled it in such an obvious way that, I don't feel like is necessarily been conveyed, in larger text. Like it was just so poignant. Yeah. So I really, enjoyed that. We'll probably borrow that for some slides in the future.
We had to do that when communicating that to over 1,000 engineers. You want everyone on the same page there. Yeah,
it's the simplest solution is sometimes, the best one, right? Yeah. So again, about SLOs, another question from the community here is, have you considered featured level SLOs to reconcile the gap between business and service or availability metrics?
Yeah, I can take that one. So feature level SLOs, that's actually pretty much what we do. So at the SLI level, we're essentially mapping what we would consider features down to these individual metrics, which serve as our SLI. And then we present our SLOs based off of those areas there. And then from there, we can then further chop it up by adding additional tags such as large accounts or whatnot, so that we can dig into that number and kind of see where, see how things are looking out availability wise. Does that answer the question?
Yeah, I think so. Obviously, if whoever asked that question, has any qualifying statements, feel free to throw it in chat or in the Q&A box, and we can always come back to it. But in terms of, I believe, questions in the box, I think we've addressed all of them. Is there any kind of parting thoughts that you have, as you've gone through some of the Q&A, anything that, you wanted to be asked? Do we want to riff on anything that you want to make sure everybody's aware of?
I think the whole, this has been a journey for us. The goal has been to ensure that, our customers are getting the highest possible, the best experience in class. And so, the Datadog tools have really, been key components there in allowing us to do that, both from, the SLO widgets, which have been huge, to the cardinality, approximation functionality of metrics without limits. That also helped us really get to a level where we can drill down and see, pretty much what the customer is seeing, just is expressed as data. And that allows us to really pinpoint where we need to focus our efforts, so that, the customers are getting that level of happiness at the end.
I think the last thing I would add on is, data is key, especially when it comes to making engineering decisions and whatnot, and being able to see your customers and how they're using your products and what they care about most and the patterns that they do. It makes having discussion really interesting, and also I would say more fruitful and beneficial for the overall company and the customers.
Yeah, it's always hard to argue with real data. makes the conversation a little bit more succinct sometimes. And I guess we do have one more question that came in from the community. It's, we kind of had a closing segue there, but we'll go ahead and answer it while we still have the time. So what SLI are you using for queue processing?
I can take that one. So queue processing is a little bit different because it's more of an asynchronous process than, say, a web request. We developed a separate version of our latency bands to have the bins aligned more with the expectations around an asynchronous process. So instead of 10 milliseconds, 20 milliseconds bands, we'll have 1 minute, 2 minute. In some cases for long, like machine learning training jobs, we'll have that go up to a week. So we've expanded that from a synchronous approach to an asynchronous approach with the same implementation by just changing the borders of the latency bands on there.
Gotcha. Awesome. Well, I think we've gotten to all these community questions. I really appreciate again you putting the time and energy to share this. I think it's a really a novel approach to solving this problem, and I'm looking forward to hearing more about it and seeing your continued success with it.
Thanks, Rick.
All right. Thanks for having us.
Thanks. Thank you again, everyone.